Following on from the previous video, we looked at the function f of x, and we defined it as x squared, and then we looked at f of 2x. Now, when to investigate f of 2x here, well, this blue line here represents f of x, meaning f of x squared here. The red line here is f of 2x. And the reason for that is when you create a table to draw this function here, if you want to know what goes in here, then you would put the 1 into this x here. So it boils down to you working out f of 2 of the old function. So to find out what goes in here, you would basically steal. Well, to find out what goes on this one here, remember 1 is only the vertical line up here. Well, to find out what goes into the 1 here, you looking at this here, what goes into the 1 here is you stealing f of 2. So f of 2 of the old function, well, this one here is 2, f of 2 of the old function is here. So it's you stealing this foot here and moving it across. I explained this in the previous video. But now, if you try and investigate what happens when you have, let's say, f of 3x or f of 4x, look what happens. Well, in the case of in the case of f of 3x, let's say you want to work out what goes in this. Well, what goes on what goes when x is 1 here, you would put the 1 into this thing here, and then that would be, well, what goes in here is in effect, or 3 f of 3. So it's like you stealing f of 3. Let's say f of 3 of the old function. So f of 3 of the old function is here, okay, because 3 here, this point here is f of 3. Now f of 3 gets moved across here, so it would be here, okay. Well, if you look at this here, if you want to know what goes in here, or when along the 2, well, when x equals 2 here, you put this 2 into this thing here, and it turns out that you have to steal the value of f of 6 of the old function. If you want to know what goes in when this is 3 here, you put this 3 into here, and then it turns out that you have to steal f of 9 of the old function. So yeah, I hope this makes sense. I know it's so strange. So if you have f of 4 of x, let's say you want to work out what goes in here, you would put the 1 into this thing here, and 4 times 1, it would be you stealing the value of f of 4 of the old function. Okay, if you want to know what goes here, you would put the 2 into this thing here, and it's you stealing f of 8 of the old function. So what that means is, looking at this one here, okay, looking at f of 4x, we have to steal f of 8 of the old function. It's gone off scale here. I can't really show you it because 5 is here, 6, 7, 8 here. 8 is here. So you would go all the way up here. Whoops, can't draw a straight line. Well, it basically means if you extend this here, let's say 8 is somewhere here, then that means it gets dragged. Let's say this is 1 here. So it gets dragged from here to here. But basically, it will become really steep. Basically, well, what I'm trying to illustrate is that looking at this table here, when you want to work out something like this, you put this into here, the 3 into here. So that would be, in effect, you working out f of 12 of the old function. So you're stealing f of 12 of the old function and putting it into here. So it turns out that it makes it steeper. So let's say this is f of x here, and then f of 2x. Yeah, every time, and then f of 3x, it would be even steeper. F of 4x would be even steeper, and so on. That's why it gets squashed inwards. It's because every time you put it into here, this here, it would be you stealing f of 16. I know this is weird. You just got to stare at it and try and understand it for yourself. This is the reason why it gets squashed inwards. Okay, I try to explain this so many times, and it is quite hard to explain. So, but if you sit down and think about it, it does get squashed in, and you can actually see why it gets squashed in.